Okay, today we're going to be learning a little bit about angles, angle addition postulate, maybe something about bisecting. No, we are going to be learning about bisecting. So just some things. So you have two words, dissect and bisect. These are two different words. One just simply talks about cutting any certain figure into pieces, right? You could dissect a frog, meaning you're going to cut its parts up. But when you talk about bisect, you're referring to cutting something into equal pieces. Now, what's something we learned that bisects recently?
Square.
Nope. What's something we learned that bisects? A midpoint. A midpoint is a bisector of a line segment. Why is it a midpoint? Because if this is 10, it breaks this line segment into two equal pieces, right? So that's important to know going forward with angles because there's going to be a couple situations. So let's say I draw Now I do have a video that I posted that talks about how to use a protractor, so see that when you're doing it. So we'll start this way. Let's look at maybe a 50 degree angle here, right? And we want to look at it a couple ways. Maybe I say that this angle ABC is bisected, which means if this is 50 degrees, then if I'm going to bisect it, I need two angles that equal 50 degrees. So if I know I need two equal pieces, I could simply divide by 2 and get 25 degrees. So when I'm using the protractor, I simply find where 25 is and create my bisector. And by demonstrating this angle bisector, I've actually demonstrated a little about angle addition, meaning two angles, let's call this the two angles that make up one bigger angle. You could say that the measure of ABD, this angle here, plus the measure of DBC, run out of space here, is equal to the measure of ABC. And we saw that with angle addition, right? We saw the same concept, AB plus BC is equal to AC. And that's the same thing here. The two smaller angles will equal the larger angle here. So let's look at a couple examples, okay? This is not so much a bisect problem as it is just simply an angle addition problem. The focus here is using the vertex HOI. So let's do this in blue and we'll call this 24 degrees. And then you have GOI, 44 degrees. And then we have our whole angle GOI. I'm sorry. Actually, this is GOH. So this isn't 44 degrees. The GOI, follow my points, GOI is 44 degrees. So actually what they're asking in this question is, what is the measure of GOH if HOI is 24 and GOI is 44. So basically you're just kind of solving for a missing piece, which we could say is a variable, and the measure of GOH is 20 degrees. And what you're saying is that this angle here that we mistakenly made 44 in the beginning is 20 degrees. So in this one they gave you the large piece, a small piece, and they asked for the other small piece that made up the large piece. And you may see other questions where they give you the two small pieces, and then maybe they ask for the large piece, and you just say, okay, this angle here is equal to 50 degrees. You will be presented with a question make sure this is in Zoom here. You'll be presented with a question that does talk about bisect here. So it's saying SQ bisects. So that means it's cutting into equal pieces. And if RST, angle RST is 50, and we already kind of looked at that in our little kind of introduction on the first page there, we're going to divide this by 2 and get 25 degrees. So anytime you see bisect, this word bisect, we're talking 2 equal pieces, 25 degrees and 25 degrees. Simple enough. The important part there is just understanding the meaning of bisect. I could say, as another example, that maybe RD bisects, maybe we would say that. And maybe I'll ask for ARE, angle R. Get it? Angle R. You get it? And if RD bisects, and I say that this is 30 degrees, and I ask for R, well then if this is 30, I know this angle here will also be 30 because it's bisecting into equal pieces. So I could say this is R, 60 degrees. Remember we talked about segment addition where we use some variables and we use like terms and we solved. This one's good too. Make sure you read the question. PNO is 2x plus 4. How I like to squeeze in this expression here is I'll kind of just point an arrow in there. And then MNO is 13x minus 4. Now I know angle addition. 2x plus 4 plus 13x minus 4 is going to be equal to the whole angle here, which we said was 60. And in order to solve for what these two angles are, I first need to solve for what my variable is. Like terms, plus 4 and negative 4 will actually cancel each other out, and I'll get 15x is equal to 60. How I do my 15s is I always know 15 times 2 is 30. So, and I know I have 30, 60, 90, 120. So I kind of always, I always find my 15 times tables kind of by my 30, 60s, just like a little side trick I do. So x equals 4, but I'm not finished. Because don't forget, they're not asking for x. And usually answer choice A is going to be 4. Because you're going to solve for the variable and think you're done. But don't forget, PNO is 2x plus 4. So we would say 2 times 4 plus 4. And then this would be 8 plus 4, 12. So my PNO is 12. And then they ask for the 13x minus 4, which is the 13 times 4. Now what I do here is I do 10 times 4, 3 times 4, and I get 40 and 12. And I'll actually do 40, 10, and 2. And I'll get 52 when I do that. That's a way for me to do mental math, minus 4, and that equals 48. And if you want to check your work, just take the 48 and the 12, add those together, and make sure they still add up to the 60 in which they already gave you.